Welcome, everyone, and thank you for joining me. It's an honor to be with you here today at the virtual SMR Summit. While we can't join each other in person, it doesn't detract from how special a group we've gathered here for this event. We have with us today those leading the charge to deploy the next generation of nuclear reactors. We have with us today the heroes that will help us transition to a clean and sustainable world. Whether you're a reactor designer, an international developer, a component supplier, heck, even a lawyer, you are playing an essential role in a critical moment of transformation. You probably don't need to hear me explain again how nuclear is the only technology capable of powering negative emissions to solve climate change. But even beyond its key role in climate, nuclear is an energy source capable of eliminating air pollution, solving energy poverty, and generating limitless clean water too. Let us never lose sight that we hold the keys to something special, something that operates in a realm of physics with order of magnitude advantages. And if we can solve the puzzle on how to translate that to orders of magnitude cost savings, we can usher in a new era of prosperity. And that's what this conference is about. It's about articulating our joint passion to create this reality. I find myself constantly inspired by the mathematicians, the physicists, the chemists, the scientists, the tradesmen, and more. It's easy to get mesmerized by what we can do, but we can't neglect to learn from the mistakes and success of the past as well. We face many issues posing challenges to collaboration and transparency. But if we are to succeed in changing the world, we must take care to democratize this technology as well. So without further ado, I present to you the Open 100, the world's first open source platform for the development, financing, and construction of a nuclear power plant. For those of you who don't know me, my name is Bret Kugelmass, and 3 years ago, I founded the Energy Impact Center with the goal of reversing climate change. Within just a few months, it became obvious to us that not only would the world require more nuclear energy, but we'd need to build about 100 times as much nuclear capacity as we have today. That's right. Our goal is to create a world that has 40,000 gigawatts of new nuclear in just the next couple decades. In the last 3 years of traveling the world, interviewing the titans of this industry, we've been trying to understand what's kept this magical power source stagnated at just 5% of global energy production for the last half a century. We arrived on a pretty simple answer. New nuclear simply costs too much. Everything that I initially thought about waste or safety or public perception turned out to be an excuse from an industry that couldn't get its act together to deliver a cost-competitive product. And in fact, every attempt to address those non-issues made power plants ever more expensive. So we came up with 2 simple rules to reset the industry, to get us back to the success of the late 1960s, when nuclear was the most competitive power source across the board at under $1,000 a kilowatt. Keep it small, keep it standard. Our thesis is that you can just stick with a standard light water reactor, shrink it to match existing supply chain, infrastructure, and capital market constraints, and this will enable delivery of the cheapest power that the Earth has ever seen. I present to you the Open 100. In collaborating with the US National Labs and several other international partners, we're publishing this work as a public resource with no proprietary technology. On our website, open-100.com, we'll be hosting the 3 key pieces of a DIY nuclear build-out. Engineering files, including CAD, P&IDs, one-lines, and architectural schematics. A construction schedule for an 18-month build-out, which is standard for all other power plants of this size. And an economic workbook to allow for the efficient financing and a turnkey business model. We've also worked hand in hand with the NNSA to make sure that this is available globally, published without any export control restrictions. Too long has this industry hid behind proprietary technology, fighting each other for an ever-shrinking slice of an ever-shrinking pie. We're launching this project to usher in a new era of collaboration and transparency, and a new way of thinking, not about the nuclear core, but about the nuclear business model. This platform is both flexible and detailed enough for utilities to engage in feasibility studies, reactor designers to leverage common engineering work, and governments to simplify licensing in order to streamline development. And if we work together to solve the one true problem with nuclear, cost, soon the whole world will realize that nuclear is not part of the solution. Nuclear is the solution. Thank you very much for embracing this mission. And if you'd like to learn more or find a way to contribute, I'll leave you with the following information to get a hold of us. I hope to see you all in person very soon. And in the meantime, just remember, you alone hold the keys to saving the world from climate change. So let's go build some nuclear power.
I would like to introduce our chairperson, who you will see with us this morning, Sean Hagen. So Sean Hagen is Managing Director at Hagen Global Consulting, and he is also Executive Vice President for Energy and Education Programs at the Institute of Global Energy Education. Sean will be our chairperson for the coming 2 days, and will be fielding all those questions that everyone's asking and fielding the panel sessions. So yeah, Sean, over to you. Thanks so much.
Thank you, Charlotte. Very interesting presentations by John, Tom, and Bret. Thank you very much for your for the information. One of the first questions that somebody from the audience has posted is for Bret, which is we need to fix the cost model, but for nuclear, but what needs to be done on the political landscape to help move this along? Sort of a social license question, if I'll put it, sort of frame it in that term.
Well, I'd push back on it being a social license question. I mean, a social license, I think, is something that the nuclear community likes to fall back on as almost an excuse making for why, quote unquote, nobody wants their product. But that's not true. We're not building nuclear because it's not cheap enough. And there are many different political landscapes across the world. And, getting through each one of them is, a totally different challenge. We're exploring this right now as we travel around meeting with ministers of energy, meeting with regulators across the world to try to understand, how can we create a safe space and ecosystem to encourage nuclear development. And it's a different consideration everywhere. I mean, listen, there are tons of places that are so desperate for nuclear right now, they love it, that they're willing to pay double for it. But they're not willing to pay triple for it. So we got to get the cost under control. That is the #1 priority.
Great, thank you. Well, that sort of feeds into what you had talked about, John. In terms of the BWRX strategy, in your presentation, you had commented the focus was on cost, sort of that, if I'm not mistaken, was one of the driving elements of your design philosophy, was it not?
Yeah, no, that's exactly right. And I agree 100% with Bret and the focus that he has on cost as well. So, we were, for decades, our focus was on large light water reactors. And we had a large project that was suspended due to the economics associated with large reactors. And so, we really took a step back and analyzed the market, talked to a lot of customers in the US, Canada, Europe. And the overwhelming theme that we heard is nuclear must be cost competitive. You got to figure out how to be competitive with all forms of generation, including gas. And there wasn't an appetite to invest billions of dollars. Really, $1 billion or less was the common theme that we saw. So it's really out of that, the market input that we collected that really drove us this intense focus on driving cost competitive solutions.
Okay. Well, sort of keeping with the theme on cost then, I know one big element of the cost you had mentioned was the amount of materials involved, especially with concrete and steel related to the containment balance plant systems. But another big element is the construction schedule. So maybe I'll ask Tom, relative to your project at NuAmps, how do you project, what's your confidence level with the construction schedule and being able to ensure that comes in as planned?
Well, I think we have high confidence at this point. We've been fortunate to have as our primary investor also our engineering, procurement, and construction contractor for our technology. So they've been involved since day one, essentially, in helping with the design and modularization aspects and developing modular construction aspects to the technology, all of which is aimed at shortening that construction schedule as short as possible. We're targeting for the first project a 39-month nuclear construction schedule, but we know that there's significant opportunity to reduce that further for subsequent plants. But we feel 39 for that first plant is conservative and it's appropriate given the first of a kind aspects of deploying the technology. But through the learning of that first plant deployment, we believe that we'll definitely be able to reduce that construction timetable further. In fact, for subsequent customers beyond the UAMPS project, we're talking a 36-month construction schedule comparison to that 39, and we still believe there's opportunity to reduce that even further.
Okay. So given that and your experience, John, how does that compare with your, I know it may be tough to call at this point, but so your conceptual construction schedule for the BWRX?
Yeah, so for our first reactor, we're targeting 3 years, and we have a lot of confidence in the ability to meet that schedule. So if you think about the advanced boiling water reactor and our alliance partner in Japan was able to construct in under 40 months. This design is a fraction of the size of an advanced boiling water reactor. So conservatively, targeting 3 years for unit 1, but our ultimate goal is to drive that down to a 2-year construction cycle.
Okay, so that brings us back to Bret. That was a fairly bold statement to get a standard construction cycle at 18 months for your open design concept. How confident are you in that?
Well, I don't think that's bold at all. I mean, if you look at any other heavy power industry and you look at their construction schedules, you're looking at 18 months. I mean, if I were to look at, NuScale's, parent company Fluor, what they can build a combined cycle natural gas plant in, same 600 megawatts, it's 18 months. That's industry standard. And that's why we've laid that out as the benchmark for the industry, for the nuclear industry, should be 18 months. If you're construction managers, if you're engineers are telling you that it's going to take 24, 36, 39 months, tell them to rethink it. Tell them they need to hire new people, hire the people that can build at the fossil industry and do it in 18 months. That is industry standard. That's not bold.
Well, first of all, great out of the box thinking in terms of for the nuclear industry. So in terms of seeking to understand and challenging, maybe instead of me asking the questions, we can have sort of a discussion. Have you looked at without getting too far into the details, but what are the key items that, have you identified the key items that sort of the long poles in the tent, if you will, on the critical path that have driven historically the nuclear schedules to the longer, multi-year schedules, that you now have assessed and think will be able to be reduced to support a shorter schedule. And again, perhaps Tom and John, you can sort of join in, and I don't have to be in the middle. I think it would be a great cross discussion between you guys.
If I may, I'm glad you came back to this, because I failed to mention the most critical aspect of our technology, and that's the fact that the power modules, which is essentially the entirety of the nuclear steam supply system and containment, as well as the ancillary equipment, decay removal, emergency core cooling, all is comprised in the NuScale power module, that fully factory fabricated component. We take there is no field construction, erection, or manufacture or fabricating at all that takes place. All of that is done in the factory, in parallel to the construction of the buildings that are there, the reactor building, the control building, and rad waste building and turbine building, which are fairly straightforward and simple buildings to construct, unlike the nuclear island for a large nuclear power plant, for example, where at times has challenged the ability of constructors to construct those facilities on time and budget. So we believe that the factory fabrication element of our technology really lends itself to the ability to drive down the construction duration to quite short time frames. If you've seen on our website, we have a Smart Plant 3D construction sequence timeline that actually shows nuclear construction culminating in 29 months. Now, as I mentioned, 36 months is our commercial commitment, but it does demonstrate the fact that the power modules are built in the factory, that we have the ability to considerably shorten that duration, approaching what Bret's talking about, which I think is quite possible in the long run after we've made several of these NuScale facilities.
John, anything you want to throw in?
Yeah, I'll just add. First of all, I absolutely love the thought process that Bret's going through, and I think logically, it makes sense that these are the kinds of goals that, from an industry standpoint, we need to compare ourselves to all other forms of generation and target those types of construction cycles. We've set some conservative targets to begin with, but certainly our goal is to try to reduce as much as possible. One of the big drivers around especially large scale nuclear is the need to do this massive excavation and then pour your base mat and you've got all the engineered backfill that's required. These are all elements of our design that have been completely eliminated. We're actually going to construct this in a circular shaft, and that construction process alone saves multiple months, and again, much less concrete. I mentioned 90% less concrete, and that's due to this design that enables a whole new construction process.
Yeah, John's right. And the thing that has historically made these projects run so far over time is just the fact that they are big. If you make projects physically smaller, you can get back in line with standard construction practices.
Okay. So size is a major issue. How about the financing cost? Is the fact that going to a modular type plant, will you be able to bring, say in a large nuclear plant, say that's operating the current fleet in the States, you had to wait quite a long while for Unit 2 to become operational, start generating revenue. Does that economic model change? Are you able to bring on modules now in operation while you're installing other modules, and therefore the financing picture changes and your economic costs in that regard change? That's sort of addressed more, well, to the group at large.
Yeah, I can start. Well, first of all, just from an investment perspective, I mentioned that we heard customers wanted a technology that was under $1 billion. And a lot of that is driven by its enterprise risk, but it's also becomes an investable project. But the way we're thinking about it is, essentially installing your first unit, get it online. While that construction process is started, you can begin the construction of a second unit. And this is if additional output is required. And you have that first unit operational, you start generating revenue, cash flows. So from a return on investment, much more economical versus building a massive plant and going after a gigawatt versus building a series of smaller reactors and generating revenue much quicker.
Yeah. Tom, any thoughts in that regard?
Yeah, absolutely. Our technology is, I think, the only one out there that's actually scalable, in that the reactor building houses anywhere from 1 to 12 of these 60 megawatt modules. So at mechanical completion of the facility, you're ready to load fuel on the first and subsequent modules. So as soon as you install that first module, you're generating electricity and generating revenue while you commission and install the remaining modules.
Okay.
So the cash flow then for our technology is quite a bit different, because the revenue is flowing much earlier than you would see in, say, a large facility or a single reactor facility. Additionally, because the power modules are made in factory in parallel to the construction of the facility, you don't have to place orders for that equipment as early as you do for, say, a large nuclear plant, where you're placing orders for the reactor vessel steam generators 5, 6, 7 years prior to nuclear construction. That changes your cash flow profile quite a bit if you're placing the orders in comparison with our technology, say 24 months prior to nuclear construction. Because those pieces of equipment don't need to be delivered early in the construction program like they do for a large plant, where the containment is built up around those pieces of equipment after they're set. In our case, the modules are delivered when the facility is ready to have them installed. They show up, you load them with fuel, you bolt them together, and they're ready to operate after the commissioning period associated with that. So cash flow profile is quite a bit different, and you're accretive to positive returns much sooner than you would be on a large plant in comparison.
So I think we have maybe a couple minutes left, but Bret, do you have any thoughts either on finance, or, since we're close to wrapping up, I was sort of curious too, I'll give you your choice on I was curious on the non-proprietary nature of your design in terms of your business model, if you can make any comments on that. They may or may not be related, but certainly, I guess, going with the theme on financing, since that's the true cost, maybe that's catching your thoughts on the, some more details on the standard economics that and financing you had mentioned.
Yeah, so just to start off with, capital's cheap. Energy infrastructure capital is really cheap. The things that has made financing difficult for nuclear is the time that you borrow capital for. So let's fix that by reducing the construction schedule, and the risk premium associated specifically with nuclear, because nuclear's had a bad track record of finishing projects. And so if you can fix those issues, you'll have access to just like ungodly amounts of capital. Now, what we're trying to do is shift away from this idea that nuclear is this is this sophisticated technology, right? Nuclear is a technology just like a skyscraper is technology. Yeah, there's engineering in there. Yeah, maybe there's some components in there that are special technology, but a skyscraper, there's no real technology to it. And we want to get the whole nuclear industry in that mentality where we switch from this idea of technology vendors to real estate and infrastructure project developers. And then you can build thousands of these units in parallel. And that should be the goal, to building thousands of nuclear plants in parallel.
All right. Well, with that, I think we can wrap up, and I will take the opportunity to put in a plug for the Institute of Global Energy Education, because what you just described, Bret, is we are not pro-nuclear or pro any technology, but we are pro accurate information about energy to non-technical people so that they are not afraid of misperceptions or inaccurate information. So we want to train non-technical people so they can make decisions with an honest and accurate understanding of how energy works. And that just was too good of a segue to pass up. So thank you very much for your time at the conference and for the segue into a plug. And I'll turn it back over to Charlotte.
Fantastic. Sean, thank you so much. And Tom, John, and Bret, thank you so much for your really insightful presentations and the question and answers there.